Okay, we're going to work a few more examples in this lesson just to get some more practice with it. But find the exact values. So sine inverse of -1/2. Our sine inverse is defined in the right side of our unit circle. So we're looking for the angle over here whose sine is -1/2, which that's the y value. So what is it? 11 pi over 6. Also, it can also be represented as what if I wrote it as a negative angle? Well, what's the equivalent location in the positive direction? Pi over 6, right? But if I go clockwise, then that's going to be negative pi over 6. Okay, these are equivalent. One's written as a positive angle and the other as a negative angle. So sometimes you might see it in this format. Just to reiterate that, so if I start here and go all the way around 11 pi 6, that's going to be a positive angle. If I were to start here and go in the opposite direction, that would be a negative pi 6. So that would be the negative pi 6. Okay, our next one is cosine inverse of negative square root of 2 over 2. So we're going to be in top regions from 0 to pi, okay, whose cosine is negative square root of 2 over 2, which is 3 pi over 4. Good. Let me write that in blue. 3 pi over 4. One more. Let's do tan inverse of -1. Okay, so the tangent is the right half. Of course, we have parentheses at each end. Okay, tangent is defined to be the sine over the cosine or the y over the x. So what's that going to be? Right here, good, because it's negative, that means one needs to be positive and one needs to be negative. So if I wrote it as a positive angle, it would be 7 pi over 4. Just for practice, what would it be as a negative angle? If I went here, it would be negative what? Negative pi over 4. Okay, you may see it in this format. Arc sine, which remember we said by definition sine inverse is the same thing as arc sine, it's just a different way to present it. So we're looking for our right half of our region, negative pi halves of pi halves, where our sine value is 0. So where's that going to be? Good, only at 0. Also, it could be 2 pi, but we're just going to leave it at 0 for now. What about arc cosine of -1? Okay, arc cosine is defined from 0 to pi, the top half of our unit circle. Where is that going to be -1? The x value, -1. Good, at pi. And the last one, do arctan of 0. Tangent's going to be your sine over your cosine, so it's going to be at 0 or 2 pi as well. 0 and 2 pi are equivalent, and they're the same location on the unit circle. Okay, our next set of examples is going to be evaluate using our properties. So we have properties, sine times the sine inverse. Let me pull those up from our previous slide. Sine times sine inverse is this first one, so it's just equal to x. So what would be our solution here? And we would say 2/3. Since 2/3 is in between, so -1 is less than or equal to 2/3, which is less than or equal to 1. So that's this first one, so it has to be between -1 and 1. So okay, what do you think about this one? So cosine times cosine inverse of -1/5. That's going to be this one right here. It's just equal to x, which is -1/5, and we need to make sure, does it fall in our region from -1 to 1? And we would say yes, since -1/5 is in between. Okay, And our next example, let's do tan inverse of -9. Okay, let's look over there. So that's this top one for every x. So yeah, so what's this one just going to be? Just -9, since -9 is a real number. Okay, so when we're working with this one, sine inverse, we can tell we're going to be working with this. So it's going to be our right half of the unit circle. But first thing, let's go calculate this. Can we simplify sine of 2 pi over 3? Let's just pull this unit circle up real quick. Sine at 2 pi over 3, the y value is square root of 3 over 2, so I can rewrite this, which can now be rewritten as sine inverse of square root of 3 over 2, and that's what we were just working on. That would give us what value? Sine value of square root of 3 over 2. Good. Pi over 3. Okay, we'll move to the next one, our cosine inverse, sums of cosine. So we're working with this region. First thing we want to do is simplify this. What is the cosine at 4 pi over 3? We can pull that up. 4 pi over 3, cosine is what? -1/2. So that's the same thing as if I rewrote this as cosine inverse of -1/2. Okay, now go to back to your unit circle and calculate that, and you get what? 2 pi over 3. Good job. And let's do one more of these. Let's do a tan. So just do tan inverse times tan of 7 pi 6. Okay, so the first thing we want to do is go to our unit circle and evaluate tangent of 7 pi over 6. So if you'll do that for me, what did you get? Square root of 3 over 3. Okay, we might need to see some scratch work on this. So tangent 7 pi over 6, we come here, it's your sine over your cosine. Have that represented here. First of all, a negative divided by a negative is a positive. These 2's cancel, so I'm just going to be left with 1 over the square root of 3. 1 over the square root of 3. Now if I come down here and I rationalize that by multiplying by the square root of 3 and multiplying by the square root of 3, this is where that value came from. Okay, so to calculate this is simplified. So first of all, we're going to be in the right half of our unit circle. This was when we had the -1/2 over the negative square root of 3 over 2. So if we go to the 1/2 over the square root of 3 over 2 that's in our region, that would be pi 6. Okay, no solution. Okay, so we may have a case which, like for example, say let me just throw this out there. If I had sine times sine inverse of 2, okay, by the property, sine inverse of x is just x. That would be 2. But what about 2? It's not in this interval, therefore this would not be a valid solution. Okay, so that's why we keep in mind where our regions are allowed. Because remember, these are the things that allow it to be an inverse because it's restricted. Because we know that our sine, cosine, tangent functions are periodic and they're not necessarily one-to-one in its entirety, only on these regions in these domains.